Okay, so today we are going to be continuing our discussion in solving equations. And today we're going to introduce equations that have the variable on both sides. So let's just kind of move into it and take a look at an example because we have all the tools we need to approach this. And so let's just begin with an example. So negative 8 times negative 8x minus 6 equals negative 6x minus 22. So let's solve this equation. So the first thing we should do whenever we want to solve an equation, it doesn't even matter if it's single step or multi-step, because if it's single step, then really this should be trivial. But the first thing we should do is simplify both sides. So we want to get both sides to look as tidy as we can. So how would we do that? Well, for this, we would want to distribute our negative 8 across those parentheses. And so what we would get is negative 8 times negative 8x, which is just going to be 64x plus 8 times 6, 48. Note the minus signs canceled both times, and so we are left with this. This is the left-hand side of the equation in simplest terms. Then we will rewrite the right-hand side of the equation, or we should, but this is what we want. We want it to be something multiplied by our x, or x divided by something, plus or minus a number without any x's in it. That's kind of what we're shooting for. We have all of our terms are combined. That's really what we want moving forwards when we solve these equations. So we get 6x minus 22. Now what we want to do is we want to get where x is entirely on one side. We only have x's on one side, and on the other side we have no x's. And so what would we do in order to achieve that, to get only x's on one side, or some number multiplied by x is the only value we have on one side, and only non-x values on the other. Let's see. And really what it would be is we would just want numbers with variables on one side and numbers without variables on the other. That would be an easier way of restating that. So in order to accomplish this for this problem, there's a lot of different ways we can do it, but I think the easiest way would be to invoke the additive property of equivalence and just add 6x to both sides. So we would get 64x plus 6x, that's 70x, plus 48 equals, this would be 0, so negative 22. We're free to add 6x to both sides of this. The only exception, the only difference when we have these variables, be a little bit skeptical with dividing and multiplying x. Typically you're fine, but remember, if x equals 0, you can't divide both sides by x. And if x equals 1 over 0, or I don't even know how that would arise, make sure you don't accidentally make a statement that's not mathematical, like 1 over 0. Not so much that's not mathematical, but make sure you don't introduce a 1 over 0 error or something like that. But for adding, subtracting, we're always good, and for multiplying and dividing, we're typically good. Just keep that in mind. So this time, everything looks like it's working out. Now all we need to do is subtract 48 from both sides. So we use the subtractive property of equivalence, and we can write 70x, so that would go away, and then negative 22 minus 48, so negative 70. And so what we end up getting here is 70x equals negative 70. And so now we simply divide both sides by 70. 70's cancel, 70's cancel, and so we get x equals negative 1. For these larger equations, I think sometimes it's nice to go through and check yourself. So let's go back through and rewrite everything, plugging in x equals negative 1. So 8 times negative 8 times negative 1 minus 6 equals negative 6 times negative 1 minus 22. And we could rewrite this as negative 8. This time I'm going to keep my parentheses in a bit later, and probably want to do that just to make sure it's obvious what's going on. So negative 8 times negative 1 would be 8 minus 6, minus 6 equals negative 6 times negative 1. We'll throw the parentheses there. So that would be negative 6, negative 1, so 6 minus 22. And so we can rewrite this as negative 8 times 2 equals 6 minus 22, or negative 16. And we see that negative 8 times 2 does equal negative 16. This equation is true, and that means our x equals negative 1 worked. So we're good. We can go up here, and we can say our solution is x equals negative 1. Okay, so good. We ended up solving through and getting it. So with that being said, what if we either couldn't solve through and get it? What if there was no solution? That's something to always kind of keep in mind, that sometimes for these equations there just isn't a solution that we can find. Something like x plus 1 equals x plus 2. If we were to try to find what x is for these, what we would get is we would take x, let's see, they are in simplest terms, so we're good on that. We would get x's on both sides, so we'd subtract both sides by x, and so we would get 1 equals 2. So that would be an example of a equation that just doesn't have any solutions, because no matter what x is, we're basically going to come to showing that 1 equals 2, and that's not right. So sometimes equations just have no solutions, and other times, like consider x minus x equals 0. No matter what I plug in for x, this will be true, and so x can be 1, it can be 5, it can be 10, and we call these, where the equation is always true, we call them identities. So this would be an identity. Okay, so with that being said, I think we can now kind of rigorously say how to solve every equation. What is the step-by-step process for solving any equation? So, and really, it's what we've been doing. So if we have something like 8 times 1 plus 5x plus 5 equals 13 plus 5x. If we were to want to solve this equation using the step-by-step process, step 1, we simplify. So step 1, simplify. My apologies. Simplify. So if we were to simplify both sides of this equation, let's see. We would invoke the distributive property. You'd get 8 plus 5x times 8, so 40x plus 5 equals 13 plus 5x. Then we would group our like terms, and so we'd get 40x plus 13 equals 13 plus 5x. Okay, so the next step, step 2, let's see, use addition or subtraction. Properties of equivalence to get variables on one side. I'm going to say alone. So we want our variables to be all on one side, and we want them to be alone. We don't want anything that doesn't have variables to also be on that side. So what do I mean by that? So if we take this equation and we perform a step 2, we would want to get all of our variables on one side. So let's move all of our variables to the left. So first thing we probably want to do is get rid of this 5x. So we would subtract 5x from both sides. And so we would get 40x minus 5x plus 13 equals 13 plus 5x minus 5x. And here we just use the subtraction property of equivalence. And what we see here, these cancel. And here we can group our like terms. And so grouping like terms, we'd get 35x plus 13 equals 13. So now we want to get our variables alone. So we need to get rid of this 13. We use the subtractive property again. As a quick note, when I say addition or subtraction properties, I'm using the inclusive or, which is just to say that it's fine to use both addition and subtraction, just addition or just subtraction. You don't have to pick one or the other, because you'll probably be using them more than once. So let's see. We subtract 13 from both sides. We get 35x equals 0. Okay? So that's step 1 and step 2. We have 35x equals 0. Now step 3, let's see here. We use the multiplicative or division property of equivalence to solve. So for this, we would probably want to use the division property of equivalence. And so we would simply take 35x equals 0, and then we would divide both sides by 35. So what that would give us is x equals 0. So good. We've solved this equation, and the original equation is 8, 1 plus 5x plus 5 equals 13 plus 5x. And if we plug in 0 for this, what do we get? We get 8 if we multiply this 8 through, distribute it through, plus doesn't matter, this will be 0, so that would just go away no matter what. And then we would have this 5 out here equals 13, and that would go away. 8 plus 5 is 13, so we're good. The solution to this equation is x equals 0. So these 3 steps that we just walked through, they will get you any equation that we have covered so far, you can solve using those 3 steps. Now, it's a bit trivial, but you can actually use those 3 steps to solve single-step equations. There's just going to be a lot of kind of just looking at them being like, oh, I don't really need to use that step. Like, for example, if I had something like 3x equals 6, this is a single-step equation. First step is simplify. Good job, we simplified. Second step, use addition or subtraction properties to get the variables alone on one side. Looks like we're good. We got our variables on one side and it's alone. So finally, we then use the multiplicative or division properties of equivalence to solve. And so we end up getting x equals 6 over 3, so 2. So that's just to say that, you know, I think sometimes in math it gets a little overwhelming when you think, oh, there's so many different types of things that we have to solve and so many different ways to solve each one of those things, where you start to feel almost dismayed that I can't remember all of this stuff. And I think it's kind of helpful just to remember that really, if you think about it, there's not too many different types of equations. If you look at all single-step equations, it's just multi-step equations, or if you solve them the same way, then you don't have to worry about a different case. If you just go into it, do those 3 steps, you'll solve any equation. And I think that can be helpful, especially if you're struggling with just trying to keep up with memorizing everything. Because that's something that I used to struggle a lot with, was just memorizing all the different ways to solve all the different equations. And so it might be helpful just to kind of remember that if you treat every equation like a multi-step equation, you can use those 3 steps to solve anything we've talked about so far. Okay, so the last thing that I'm going to do is just solve 2 other equations that are special cases that I think it's good to see them occur. So if we have 7x plus, let's see, 5x minus 1 equals negative 5 plus 12x. So let's solve this equation first. And so let's just follow our 3 steps. Step 1, simplify. So we can simplify this as 7x plus 5x minus 5 equals negative 5 plus 12x. We can further simplify this equation by combining our like terms, and we get 12x minus 5 equals negative 5 plus 12x. Okay, so now we have finished step 1. This is the simplified form of the equation. Now we can do step 2. And so for step 2, all we're going to do is examine or use the additive and subtractive properties of equivalence to get all of our variables on one side and make sure they are alone. And so let's remove 12x from this side, and so we would subtract 12x from both sides. So 12x minus 12x is 0, minus 5 equals negative 5, plus 12x minus 12x, 0, and really we don't need to worry about that. So we just get -5 equals -5. Uh-oh. So this seems a little bit troublesome. Where do we go from here? But really, we've solved it. There is nothing more to go from here because we're done. We've shown that no matter what value I put in for x, I get to a statement. And is this statement true or false? -5 does in fact equal -5, so this is true. Great. That means our equation is always true. So, this is good. We have solved this equation, and we've shown that this equation is always true. So, we are done solving. This is going to be an identity, and so, great. This equation is an identity. Okay, so let's see what other equation. 6, and let's actually get a new slate. So 6y minus 5 equals 2, 10 plus 3y. Okay, so if we were to solve this equation, how do we go about doing it? So part 1, or step 1, we would simplify both sides of our equation. And so we'd get 6y minus 30 equals 20 plus 6y. And this is now in its simplest terms. We have simplified this equation, and so now we can move on to step 2. So, step 2, we'll be using the additive and subtractive properties of equivalence in order to rewrite this equation, getting our variables on both or on one side and making sure they're alone. So let's see. We would subtract 6y from both sides, and so on this side 6y minus 6y is 0, and so we just get 30 equals 6y minus 6y, again 0. -30 equals 20. Again, there's not really anywhere we can go from here, and so now we just need to ask ourselves, this thing that we've got to, is this true or false? -30 does not equal 20, so this is false. That means no matter what value that we plug in for y, this equation is incorrect. That means there is no solution for this equation. And so we can say that. No solution. And we're done. Okay, so that is kind of everything that we need to know of how to solve single-step equations, multi-step equations, and multi-step equations where we have variables on both sides. Hopefully this made sense. Hopefully it helped. And I think the biggest takeaway from the last 3 of these videos would be to always use those steps. If you're ever stuck, just use those 3 simple steps. Simplify both sides of your equation. Use the addition and subtraction properties of equivalence to get your variables alone on one side. And then finally use the multiplicative or division properties of equivalence to solve the equation. And then know that sometimes if you get to a point where your equation has become a statement, a 2 equals 3, 2 equals 2, that statement will be true or false. If it's true, then your equation is an identity, and it is just always true for any value. And if it's a false statement, that just means there's no solution, and you just, no matter what variables you plug in, that equation is going to be incorrect. So hopefully that helped. Thank you very much for watching.